Hi students, this is El-Refaei, math teacher for both AS and A2 level. Today in this class we are going to talk about the remainder theorem. I hope you watched last class. We were talking about the factor theorem, and today's class is not that much different comparing to the previous class. It's the same, but today we're going to talk about the remainder, any value but not zero. Let's start by question number 1. Use the factor theorem to find the remainder when x cubed plus 3x squared minus 10x minus 24 is divided by x minus 5. I'm going to use the same steps for the factor theorem. So x minus 5 equals 0, x equals 5. I'm going to substitute 5 in the function, 5 cubed plus 3 by 5 squared minus 10 by 5 minus 24. 125 plus 75 minus 50 minus 24. The answer will be not 0. The answer is 126. So the remainder is not a 0, it's 126. According to that, this x minus 5 is not a factor. Not a factor. How I discovered it's not a factor? I discovered it's not a factor by substitute x equals 5, and the answer is not 0, it's 126. Okay, why I did not use the long division? I did not use long division because they told me to use the factor theorem and find the value of the remainder I will have. To find just remainder, no need to use the long division method. If I look to part B, find the quotient and the remainder. In this case, I have to use the long division method because I'm talking not just remainder, I always need to find the quotient. So no need to use what we're going to call it, because the remainder is not a 0, it's 126. We're going to call it the remainder theorem. I'm going to use the remainder theorem because the remainder is not a 0. So I'm not going to use the remainder theorem, I'm going to use the long division method. X cubed plus 3x squared minus 10x minus 5 minus 24, divided by x minus 5. X squared, x cubed minus 5x squared, 8x squared plus 10 minus 10x minus 24 plus 8x, 8x squared minus 40x. It will be 30x minus 24 plus 30x minus 150, subtraction 0, negative 24 plus 150 equals 125. Look carefully, I had 125, this is 126, yes, 126 is 24. So I had the same as I used the remainder theorem. They are the same, but I use the long division method in order to find the quotient. So if the question is just talking about the remainder, only use the remainder theorem. If the question asks for both quotient and remainder, use the long division method. Let's move and solve more complicated questions, more past paper questions, where I'm going to combine between the factor theorem and the remainder theorem. Question number 2, it's 5 marks. The polynomial 2x cubed plus ax squared minus 11x plus b is denoted by bx. It's given that bx is divisible by 2x plus 1. As I said, divisible, it means this is a factor and the remainder is 0. And that when bx is divided by x plus 1, the remainder is 12. Find the values of a and b. I'm not going to use long division because I have two unknowns, A and B. I'm going to use the factor theorem, the remainder theorem. I'm going to have two equations and solve them simultaneous. Let's start. It's divisible by 2x minus 1. So 2x minus 1 equals 0. So x equals half. F half equals 2 by 1 over 2 cubed plus A by 1 over 2 squared minus 11 by 1 over 2 plus B, and it will be equal to 0. Y equal to 0, it's divisible. 1 over 4 plus A over 4 minus 11 over 2 plus B equals 0. To simplify it more, I'm going to multiply the whole equation by 4. It will be 1 plus B minus 22, 1 plus A, 1 plus A minus 22 plus 4B equals 0. More simplifying, A plus 4B equals 21. This is equation 1. I took it from the factor theorem. Let's use the remainder theorem. X plus 1 equals 0. So x equals negative 1. F negative 1 equals 2 by negative 1 cubed plus A by negative 1 squared minus 11 by negative 1 plus B equals 12. Negative 2 plus A plus 11 plus B equals 12. More simplifying, A plus B equals 3. This is equation 2. I'm going to solve these two equations simultaneous by using elimination. A plus 4B equals 21. A plus B equals 3 minus 3B equals 18. So B equals 6. A plus B equals 3. A plus 6 equals 3. So A equals negative 3. I hope question number 2 is clear, students. Okay, let's move to question number 3. Last question. 5 marks. The polynomial x to the power 4 plus 3x cubed plus ax plus b, where a and b are constants, is denoted by bx. When bx is divided by x squared plus x minus 1, the remainder is 2x plus 3. Find the values of a and b. I choose this question because I'm not going to use the remainder theorem. Why? Because the remainder is an expression. So I'm going to use the long division method. And the remainder is an expression. Let's do the long division. X squared plus x minus 1, x to the power 4 plus 3x cubed plus 0x squared plus ax plus b. X squared, x to the power 4, x cubed minus x squared. 2x cubed plus x squared plus ax plus b plus 2x cubed plus 2x squared minus 2x. negative x squared plus a plus 2x plus b plus 1, negative 1, negative x squared minus x plus 1. And the remainder is 2x plus 3. According to that, I will have two equations. The first one, a plus 2 minus negative 1 equals 2. A plus 3 equals 2. A equals negative 1. B minus 1 equals 3. So B equals 4. I hope today's class is clear. Solve past paper questions, solve book exercises. See you in chapter 2. See you there.